Hi, my name is Kayla Clausen and I'll be talking to you about my time in Shanghai whilst teaching science. So when undertaking the placement in Shanghai International School, the process of planning and teaching a small-scale investigation was not undertaken completely, although multiple lessons were taught with guidance by my mentor solely for the assignment. So the following evaluation highlights what I taught, what I observed, and what I learnt from my time in Shanghai as a pre-service teacher. So the investigation was planned prior to starting placement, meaning that not all requirements of the assessment have been met. So taking on the role as the teacher, I tried to adapt the mentor's lesson to carry out a mini investigation, which saw students successfully explore their surroundings through scientific analysation and questioning, whilst obeying by the mentor's strict instructions. On my third week of placement, I had the opportunity to teach 2 double lessons on the topic of shadows to half the Year 4 cohort. So the topic aligns with the Year 5 subject strain of physical science, which was light from a source forms shadows and can be observed, reflected and refracted. So this meant that students were understanding and clarifying materials as transparent, opaque and translucent based on whether light passes through them or is absorbed. The topic allowed students to develop, understand and investigate the concept of light through engaging scientific activities in a way that allowed students to answer interesting and important questions in an empirical way on the basis of their physical world. So the initial aim of the double lesson was for students to recognise that shadows are formed when light from a light source is blocked by a solid object through investigating the mesh material for their curtains in their bedroom. So the science inquiry skills used within investigation include I can explain how light travels, I can sort different materials according to whether they are opaque, transparent or translucent, and I can use these materials in an investigation into different shadows. As this was the first and only lesson taught on both classes, I was unaware of the students' prior knowledge in regard to shadows, although it was evident that students had a developing understanding that mirrors can be used to reflect light onto different objects and why mirrors are good reflectors. It was mentioned in the textbook that students' prior knowledge is deemed vital in the teaching and learning process, hence why it was important to implement activities and or discussion that allowed students to make sense of their world and scientific ideas learnt prior to this. So when starting the shadow lesson, I used the students' prior knowledge of reflection to create a group discussion and gauge where students were at in their understanding of light using a different concept. Through learning drawn from course experiences and associated readings, I understood that teachers, including myself, had to explicitly discuss and teach students the specific aspects of the science within the context before actually completing the doing of science. In addition, and according to the textbook, teaching primary science allows teachers to inform students what is meant by light and take an unproblematic and obvious answer to the next level. By doing this, I was investigating what students understood as well as covering a range of interesting conceptions through natural curiosity and critical thinking. So implementing learning experiences that were hands-on encompassed the learning of science within the class, evident throughout the lesson, which isn't necessarily what the Chinese culture is about normally. So the learning sequence consisted of how light travels, addressing the student misconception that light can travel in a non-straight line. So through explaining the misconception, students were to create a model or experiment that demonstrated that light travels in a straight line, which can be evident in my lesson plan. Whilst completing the experiment, students were asked questions that generated and prompted science inquiry for the investigation. So by the students creating these science inquiry questions, they were becoming active participants within the lesson. The questions that students planned to inquire were modelled by myself to reflect the depth of thinking I expected from the students. So the initial question based around the investigation to be inquired was, what curtain material would be used to block out light? So before modelling that, I gave the students this question which we discussed as a class. What does it mean and how could we present this information? So using this initial question as a starting point for the students, they were applying their knowledge learned into different contexts, such as their bedroom or the classroom, to engage in higher order thinking. So students within the international school found it difficult to become effective questioners through inquiry, as it was uncommon to their normal learning practice. So after investigating that light travels in a straight line through experimenting, we heavily focused on opaque, transparent and translucent objects, focusing on the fact that opaque objects blocked light, and we used several different resources within the classroom to understand what the differences were between the 3 terms. So through exploration and greater discussion of the three terms, students were given the opportunity to make hand shadows using the projector and smartboard, which were as opaque objects to block the light. By integrating exploration activities, it was ensured that students were developing a conceptual understanding of shadows, as well as a perseverance and open-minded questioning throughout. Unlike in Australian schools, incorporating a constructivist teaching model was harder than what was anticipated. Within the lesson, teaching strategies that aimed to orient and engage learners were implemented but not necessarily mastered. So according to the textbook, classroom context, student goals and expectations and needs, as well as their interests, are common attributes that should be considered when incorporating a constructivist approach. Although the lesson was planned by a mentor teacher, it also meant that there was limited conceptual change due to the strict demands of mandated exams the following week. So through the investigation, students were using the knowledge they have learnt to write a detailed explanation about the science they have learnt in the investigation. As the teacher, I was looking for students who could communicate their understanding of how opaque materials block light, the science inquiry skills that were targeted, and the concept skills learnt through carrying out the investigation was to effectively recognise that shadows are formed when the light from a light source is blocked by a solid object. Through the investigation, students were able to identify if different materials could be used as curtains to block out the light. Exploring students' ideas about the light sources and more specifically shadows that could be absorbed, reflected and refracted provided students with an elementary scientific basis of the concept energy, as well as providing the opportunity for enriched learning activities throughout the class. As a pre-service teacher conducting the lesson, I learnt that international schools more so should show more emphasis on teachers guiding extended inquiry. So instead of presenting and teaching science through textbooks, allowing students to explore using concrete materials around the classroom and as a group may be more beneficial for the students. And student engagement was successfully supported by pedagogical ideas such as affective questioning and group inquiry to emerge student knowledge. Overall, in order to understand the science of light and shadows, it was important that both myself and students within the learning process recognize that it was the body of knowledge accumulated from the concepts, theories, and discussions taught as a group that generated our understanding and questioning throughout the whole investigation.